Welcome to this XDK2MAM video tutorial for the USB microSD package. Today I'll be guiding you step by step through the process of connecting Bosch's XDK110 device through USB to a listening device and set up a Node.js server that will retrieve that data and publish it to the Tangle using Masked Authenticated Messaging or MAM. The device that will be listening via USB in this example will be a Raspberry Pi 3 with Raspbian OS. But you can use any other device with USB connectivity that accepts Node.js code. So let's see what we'll be using today. Xdk Workbench is an Eclipse-based IDE. If you don't have it installed, you can go to xdk.io. In the download section, find the version that suits your OS. This software is essential to import the code and flash it to the XDK110. You will also need to have Node.js installed. You can get it by entering nodejs.org and downloading the version that suits your system. If you want to know whether you have Node.js installed, you can type the command line node -v. If it returns a version number, then it is already installed. The git command line is going to be very handy for this method because it won't only help you install the repository, but it will allow us to use a command line that uses SSH, which is the method we'll use to access the USB device. As we said, the Raspberry Pi in this case, but you can use any other SSH command lines if you prefer so. So, to begin, we'll go to the XDK2MAM website and into the section The Code. Here you can find different solutions to send the census data to be published in the Tangle. Today we'll be using the USB microSD package. This method uses a microSD card to store the config file. This implies more portability as all settings will be saved on the microSD that goes into the XDK110, and you can easily modify the config file should you need to. Otherwise, every time you want to change some settings, you would have to recompile the code and flash it to the XDK110, which is far more cumbersome. Another advantage of this method is that the USB cable that will be used for transferring the data from the XDK110 will also serve as its power supply. That means we make sure our XDK110 won't be running out of battery. So here I'll copy the repository and go to the command line to do a git clone that will copy everything we'll need to the C drive. When we go to the folder that was just copied to our drive, we can see a folder called XDK2MAM that contains the different methods to connect our XDK110, including USB. Inside that folder there's a config file. So first of all, we have to copy that file onto the microSD card and then open it. Here you can change the device name, which is very useful if you want to easily tell apart your devices when you have several of them working, and you can modify the request interval in which the XDK110 sends the data. It's expressed in milliseconds here, so the data will be sent every 30 seconds. And here we can choose which of the sensors will be included in that dataset. As you can see, everything's on by default, but you can change that if you want to. So save these changes and eject the microSD card. Then plug it, contacts up, into the XDK110's microSD slot. So the next step is to open Xdk Workbench, then go to File, Import, Projects from Folder or Archive. Next, Directory, and browse the folder we just downloaded. Then go to the USB SD card folder, XDK2MAM-C. That's the folder we were looking for, so click OK, then Finish. Now we must right-click on the XDK2MAM in the Project Explorer panel and select Clean Project. After the cleaning is complete, right-click once again and choose Build Project. This is going to compile the project. Depending on your CPU, this might take several minutes. The compilation process ended correctly. Don't worry if you get some warnings, that's normal, as long as it states that the compilation was correct. Now connect the XDK110 to the computer USB port and then turn the switch to on. Next, we'll be flashing the code by clicking this button. We have to give it some time, And as soon as it finishes flashing, the XDK110 is going to start sending the data. And this is it, the first dataset. But the USB device is not listening for that data yet. Now let's head to the Git command line. As we already said, this particular command line will help us connect to the Raspberry Pi. Now I'll type SSH space pi at and my Raspberry Pi's IP address on this Wi-Fi network. Then we must enter the password for the default Pi user that we defined when installing Raspbian. Now we get this pi at Raspberry Pi prompt. So what I'll do is list the current directories, and I'm going to make a new directory called Xdk-USB tutorial and then access that directory. We'll have to download again the whole repo here into the Raspberry. To do that, we'll copy the GitHub repo once again and do a git clone. Once all dependencies are installed, we can see folders have been created for the different available methods. Now we'll enter the USB-SD card. And in here we have a Node.js folder that we need to access in order to install all the modules. And that has to be done before we can edit the XDK2MAM USB.js file. But before we do that, we should note here that the USB method is based on the Tessel library. So this library requires some packages to be installed beforehand that will vary according to the OS of your device. In the README file for the XDK2MAM USB package, you'll find a link to the Tessel repository where you can find what the required dependencies are for your OS. In this case, I have to download the Linux packages. They are detailed here, as you can see, so we have to run the following commands. I'll just copy and paste them one by one. If they happen to be already installed, it will say so, as in this case. This step of making sure the Tessel libraries are installed in our device is essential for the method to work. Now I'll type npm space pi. We have to give it some time. So, now we can see the required modules that have been installed into the Node.js folder. And we can see a file called xdk2mam-usb.js that we need to edit. Since we're at the console, we can't use a graphic IDE, but we have to use a console editor. I choose to go with Nano, one of the most commonly used editors in Debian-based systems, but you could also use some other editor like Vi, for example, if you preferred. So we type nano and the name of the file to be edited. The first thing we must edit is the full node data. If you don't know which node to use, you can enter iota.dance and choose one of the full nodes available there. Make sure it has proof of work checkmarked and copy the node and port data. These IDs should work in Linux systems, but if they don't happen to work for you, you can change them. If that's the case, in the README file you can find the method that will let you know the ID for your USB ports. In this case, it shouldn't be necessary to change them, so now we must save these changes by pressing Ctrl plus the letter O. We are now asked whether we want to overwrite the file, so we hit Enter and then press Ctrl plus X in order to exit. And we're back at the console. Now, there's just one thing missing for the USB device to be able to start listening. We will need to use sudo node xdk2mam-usb.js. When we finally press Enter, the Raspberry Pi will promptly start receiving the datasets sent by the XDK110 through USB. We should get the root number back at any moment. And this is it. If you don't get the root after several datasets have been sent, that probably means that the full node you chose from iota.dance is not running correctly, so you just have to go pick a different one and edit it back into the settings using Nano. If you want to make sure your datasets are being published correctly to the Tangle, you can copy this root and then enter thetangle.org. Go into Services, MAM Decoder, and paste it here. Then click Decode. And here we can see the datasets that are being published to the Tangle. You can see the data sent from our sensor is displayed here in trytes, JSON, and TXT. So we just sent the XDK110 sensors data to the Tangle using the XDK2MAM USB microSD card package. The datasets are now decentralized and unchangeable. And this is it for today. Thank you for viewing this XDK2MAM video tutorial. For more information and resources, go to xdk2mam.io.